Welcome to EDU World Space.
Now, in this problem, we have a ball on a wire here, and it's swinging around here. The angle that it makes with the vertical here is, we were given that, right? Thought we were given that. Let me see, did I not write that down? Oh, well, we weren't given that because we were given other information that we can find it. So we know that this radius here, that's what we were given, I think. No, actually we weren't given. We don't need any of this. Okay, that's right. So we have this initial length. We know the diameter of the wire. We know the mass of this ball. We want to figure out how fast this thing should be spinning around here so that we get a 1 microstrain or millistrain, which is 1 times 10 to the minus 3 for a strain. And we're told that the wire, the Young's modulus for the wire is, what would that be, 70 gigapascals. So we know the force in the radial direction, coming out here, I guess, and is the mass times acceleration in the radial direction. And we know that the tension is just the force times the sine of this angle here. And that is the mass times the radius here times the angular velocity squared. This is the radial acceleration. That we know the sine of this angle here is the radius divided by the initial length. And so when we plug that in to here, we can see that the radius cancels out, and that's why we aren't given it, because it falls out in the end. So we get that T equals the mass times the angular velocity squared times the initial length. Now we know that Young's modulus is the stress divided by the strain. And we were given the strain is 1 times 10 to the minus 3. So we get the force is the stress here is the force in the wire, which is T divided by A. And then I just move this up to the numerator, so we get 10 to the third. Well, if you solve for T, we get Y times A times 10 to the minus third. And that we know is m omega squared, the initial times the initial length. We need to find the area from the diameter. We can do that. And then if we solve for omega, we get this expression here, and plugging in all our values, we get 5.73 radians per second.